All right, guys, this is going over redox reactions. So redox is just a different way of looking at some of the reactions we've done. 4 of our 5 types, everything except double replacement, is considered a redox reaction. It's any reaction where we have charges changing, and the two always go together, reduction and oxidation. In order to be considered a redox reaction, electrons move from one atom or ion to another. So this is an example of a redox reaction. It's not in your notes, but you have everything you need there. Sodium chloride forming from the elements sodium and chlorine is considered a redox reaction. It's also a synthesis reaction. So in the formation of sodium chloride, sodium is giving away an electron to chlorine, and both of them have their charges changing. So this is considered a redox reaction. In this reaction, the sodium would be oxidized because it is losing electrons, and the chlorine is reduced because it's gaining electrons. Now that sounds backwards, because if you're gaining electrons, why are you being reduced? But because electrons are negative, we actually look at the charge to tell us which is oxidized and reduced. So sodium goes from 0 to +1, that's an increase, and chlorine goes from 0 to -1, that's a decrease. So that one is reduced. So the oxidation numbers are basically the charges, and that's what we're mainly focusing on here. Oxidation number is increased for oxidation and decreased for reduction. So here's our summary of oxidation. Losing electrons, the oxidation number goes up in a reaction. Here's our reaction again, chlorine goes down, and our summary, reduction is gaining electrons and a decrease in oxidation number. One way to remember which one's which is Leo says GER. Leo stands for lose electrons, oxidation. GER, gain electrons, reductions. So in order to tell if a redox reaction is happening, we need to look at their oxidation numbers. So to figure that out, we're mostly doing charges, but some of the elements are going to be a little different than we've done before. So our rules are that if it's an element, it's going to be 0. That includes the diatomics. So you see O2 here is 0, just like the other ones. If it's not bonded with a different element, the oxidation number is 0. In compounds, fluorine and oxygen, as well as the metals that only have one charge, those ones tend to always be the same. Some elements, like the transition metals, can change, and some of the nonmetals, if you look at your periodic table that has the charges, some of the elements have more than one number. If that's the case, you use the other elements in the compound to figure out what it is. So one of the helpful ones here is that the sum of the oxidation numbers in a compound is going to equal the charge for that compound or ion. So if it's a neutral compound, all the oxidation numbers add up to 0. If it's a polyatomic, they add up to the charge of that polyatomic ion. And then we always do the elements that have multiple charges last. So we're going to work through some examples and see these rules in action. Okay, so our first two are sodium and phosphorus. They are both elements, so they're not combined with anything else, so both of them would be 0. With these, you should have the oxidation number written above the element. Okay, second reaction, NAF. So this one, if we look at the periodic table, fluorine is always -1, and also sodium is always +1. And we could also figure that out because we have to have them add up to 0. So sodium has to be +1 in order for that to be neutral. Okay, in this one, if you look at your periodic table, sulfur has multiple charges, but because it's written second, it's going to be negative. Mg is always +2. So that means that in this compound, sulfur has to be the -2 one to add up to 0. But this is why we have the multiple numbers written, because sulfur can change. Okay, for this one, oxygen is always going to be -2, and carbon can change. So we do oxygen first, and we say that in order for this to add up to 0, carbon must be the +2 version. In this example, again, oxygen is going to be -2. We have 2 of them. So that means that that's -4 overall. In order to add up to 0, sulfur has to be +4. Okay, this compound is technically written backwards because usually we write the positive one first. Hydrogen is always +1. And then because of that, we have 3 +1s. Nitrogen has to be -3 to add up to 0. In this one, we're going to do the 2 outsides first, and then do the middle one, the carbon, last. So because we have multiples of both, some people like to add up the total charge on the bottom if you're working on paper. So in this one, sodium's always going to be +1, and oxygen's always going to be -2, but carbon can change. We have 2 +1s from sodium. When you write the number, the oxidation number of Na is +1, but that's +2 overall. Oxygen is -2, but we have 3 of them, that's -6 overall. So right now, that +2, -6 adds up to -4. In order to equal this out to 0, carbon has to be +4. Okay, that was our last example.